So, here we are giving the video solution for the third assignment of the course solid state physics. So, our course is solid state physics, and here we are giving the solution of assignment 3. Assignment 3 is video solution. So, let us see what are the questions. Come to the question first. The first question, that which of the following notation represents the direction of a plane? See, some notations are given A, B, C, D options. A is actually when written in the first bracket, it is actually the Miller indices you know, and when in the second bracket it is the family of planes, and the third bracket is the direction of the plane. So, that is H when written like this HKL. So, question 1, its solution is option the third bracket, that is HKL in third bracket. So, option C is the correct. Then come to the question number 2. Question number 2, which of the following statement is correct for NaCl crystal? The question number 2, you may see one image here. You see one image first for the NaCl. See the image. It is very clear that those the red one sodium atoms and the green or blue sorry, it is the chlorine ion, all are ions here. And you note that actually if you consider this cube, this whole cube, you see that there is what? There is, if you see this middle one chlorine, you see that at the each face there is a red, I mean sodium ion. At the corners, at every corner there are sodium ions. So, at each face there are sodium ions, and each corners there are also sodium ions. So, that means what? That means very simple, that in this case it is the actually FCC lattice with 2 atom species. So, question 2 its solution is which option? Which option is correct? You see which option is the correct one? It is D. Okay. So, it is D option, option D, that is it is the FCC lattice with 2 atoms basis. So, this is the answer for the question 2, FCC lattice with 2 atoms basis. So, now come to the next one, question 1 and 2 over. Come to the third one, third question, that is what? What is the question? Check the question first. Third question, the ratio of spacing D between the successive planes 1 0 0, 1 1 0, 1 1 1. So, how to for the simple cubic lattice? So, simple cubic lattice means here the parameters A, B, C are same, and we know the very well known relation for the interplanar spacing D for the simple cubic, A by root over of H square plus K square plus L square. Which question we are discussing? Let us write question number. Question number is what? Question number 3. Question number 3. Okay, question number 3. So, D is this well known formula, root over of H square plus K square plus L square. So, the planes which are there are, one is your 1 0 0, then 1 1 0 and 1 1 1. So, planes are 1 0 0, 1 1 0 and 1 1 1. Let me check have I written correct or not. Yes, 1 0 0, 1 1 0 and 1 1 1. So, let us find for 1 0 0 plane first. D 1 0 0, it is your a by root over of 1 square plus 0 square plus 0 square, that is actually a. Similarly, for the next one D 1 1 0, it will be a by root over of 1 square plus 1 square, that is root 2. And similarly, D 1 1 1, it will be a by root over of 1 square plus 1 square plus 1 square. So, that is 3, a by root 3. So, thus, if we find the ratio, if we want to find the ratio, see, so D 1 0 0 is to D 1 1 0 is to D 1 1 1. It will be simply your a is to a by root 2 is to a by root 2 is to a by root 3. Now, after simplification, if you simplify this, then you will get this value 1 is to 0.71 is to 0.58, 1 is to. So, this will give you 1 is to 0.71 is to 0.65, I think 1 by root, it is how much? This is 0.58, 0.71, 0.58. So, this is very simple, 0.58. So, which option coming correct? You may see the options, option B is correct for question number 3. So, option B is the correct one. Let me see if I have, yeah, it is option B. So, option B is the correct solution. Okay. So, question 3 is over. I think there should not be any doubt with this. Now, next question, that is question number 4. We will come to the next question. So, start with question number 4. Question number 4. So, let us see what is the question first. Let us see the question. What is the coordination number of sodium chloride? What is the coordination number of sodium chloride structure? Here also it will be better if you see the image. Okay. Coordination number we know that is the number of nearest neighbors. So, if you see, suppose if you consider this one, this blue, I mean chlorine, then see its nearest atoms are or ions are which? This is 1, this is 2. Another one here it is 3. Come to this side 4, go down another one 5 and come up another one 6. So, answer is very simple, it is only 6. So, for the question number 4, answer is 6, that is option C. Yes, option C is the correct. So, question number 4, option C is correct. Option C. Okay, question number 4 is over. Now, come to the next one. Question number 5. So, come to the next question, question number 5. An n-fold symmetry means rotation of angle dash will repeat the object itself. Actually, if the object appears identical after a rotation of say, after a rotation of 180 degree, say 180 degree, that means twice in 360 degree, that is in 2 pi, that is equal to 2 pi. Then the then it is called two-fold symmetry. Okay. Let me change the question number, otherwise there may be confusion. Let me change the question number first. Similarly, if after 90 degree rotation it appears identical, I mean twice, I mean 4 times in 360 degree, then it is called four-fold symmetry. So, this way if the n-fold symmetry means, so n-fold symmetry means the rotation of the angle 2 pi by n, radian will repeat. So, the answer will be 2 pi by n, this answer will be 2 pi by n for n-fold symmetry, 2 pi by n. So, which option is correct? Option D. Option D. Option D. This is for question number 5. So, option D is the correct for question number 5. Next question, it is also from symmetry, operation. Which question? Question number 6. Is it? Question number 6. Yes. A regular hexagon has dash fold symmetry. A regular hexagon. So, let us draw one regular hexagon here. Let us draw one regular hexagon. So, like this, all sides are equal and these all angles are also equal. All angles are also equal. So, here what is the angle value that you can easily find? The total angle is how much? You can see if this is theta and this is a phi, then theta plus phi is equal to your pi radian, I mean 180 degree. This is also theta and phi, because this is the your regular hexagon. So, this way you can calculate the total external angle how much and total internal angle how much. So, from there you can see that this one actually has 6-fold symmetry. I mean in 360 degree, I mean at 2 pi radian, it appears identical 6 times. It appears identical 6 times. So, here also the correct option will be option D. Here also correct option will be option D. Then next question, question number 7. Question number 7. So, next question is question number 7. What is the question in 7? There is the image you see. Actually, here if you note carefully that the figure 1 and figure 3 are actually same. How? Let us show it. Actually, figure 3 is what? Figure 3. Figure 3 actually, if you see, it is something like that, okay. Then something like that. So, what you do? You extend this way. You see, this is actually the part of a triangle, like the first figure. So, this is actually the part of the triangle. So, your figure 1 and figure 3, those must have same fold symmetry. So, option B will be the correct. So, we discussing question number 7 and option B is correct. Option B is the correct one. Option B. So, I hope it is clear. Actually, here we have removed some part of the triangle, that is why there may appear some confusion, but after this drawing is complete, I think there will be no doubt. Now, come to question number 8. Question number 8, here is the one direction is given. In the third bracket means direction and bar means it is negative. So, 1 bar 1 0, in which plane it will lying. So, let us see another image also for this. Yeah, see this 1 bar 1 0 line is shown here. You see 1 bar 1 0 line is shown here. Okay. So, actually, and in which plane it is lying, that is also shown. It is 1 1 1 plane. Alternately, you may also see that your answer is correct. How? Okay. So, we discussing question number 8. Let us remove question number 7. You know that if it is lying in the same plane, say your HKL is the mirror indices and say UVW is the direction as I have written in the third bracket, then HU plus KV plus LW, it gives 0. So, here it is 1 1 1 and here it is 1 bar means minus 1 and this is 1 and this is 0. So, this way this will be 0. So, this way you may also check, you may verify this matter and then you will see that your it is lying in the 1 1 1 plane. So, it is lying in the 1 1, yes, it is lying in the 1 1 1 plane. So, option D is correct. So, option D is correct for question number 8. Okay. So, question number 8 is over. Now, the rest 2 questions. In this assignment, we have given less number of questions, only 10. So, question number 9, let us come to the question number 9. Question number 9, calculate the angle between 110 and 111 planes. Question number 9, calculate the angle between 110 and 111. 110 and your 111 plane, yes. So, this is your question number 9. Okay. So, we know that the angle between the 2 planes is given by this cos theta is equal to your H1 H2 plus K1 K2 plus L1 L2, where H1 H2 H1 K1 L1 is the Miller indices for one plane and H2 K2 L2 are the Miller indices of one plane, divided by root over of your H1 square plus K1 square plus L1 square into L1, yes, L1 square into H2 square plus K2 square plus L2 square. So, your H1 H2, so your planes are, one is your 110 and one is 100. So, planes are 110 and 100. Is it 1 or anything else? No, 110 and 100. These are the planes. So, apply this formula and put the data here. Your H1 H2 will be 1, this is 0, this is also 0. Now, divided by root over of, for the first case, 1 square plus 1 square plus 0 square and into this is only, okay, this is only 1 square plus 0 square plus 0 square. So, this is coming 1 by root 2. So, when cos theta is 1 by root 2, your answer must be theta is equal to 45 degree. Your answer will be theta is equal to 45 degree. So, that means your which option will be correct in this case? Your question number 9, it is 45 degree, I mean option B. So, this is question number 9 and solution answer is option B, that is 45 degree is the correct answer. Answer is 45 degree. It is the option B or not? Yes, it is option B. So, this is the solution for question number 9. Okay. So, now the last question. The last question is regarding that packing fraction, but it is a special type of crystal as we discussing. The last question is here, calculate the packing fraction of sodium chloride from following data. What is given? The radius of the sodium atom ion is given, it is 1 angstrom, and that of chlorine is also, it is 1.8 angstrom. Okay. So, you have two atoms, 2 ions actually, one is the sodium and another is the chlorine. So, sodium, okay, question number 10, sodium, its sodium ion and its radius is given R Na plus, let us write like this, it is 1 angstrom, and chlorine ion its radius is say let us write like this, it is your 1.8 angstrom. So, what will be the lattice parameter in this case? This lattice parameter is very simple. You actually the lattice parameter is this much. Okay. So, actually a lattice parameter yeah, so sodium plus chlorine. So, the lattice parameter A will be 2 into the radius of sodium plus radius of chlorine. So, this way if you calculate, you will get 2 into this is your 2.8 yes 2 into 2.8 all right. So, this is 2 into 2.8, that is actually 5.6 angstrom. So, this is the lattice parameter A as I have written. Now, for the sodium chloride structure I have already shown you many times. Actually, it is in this case the number of lattice points per unit cell is 4. Number of lattice points per unit cell is 4. So, packing fraction, or we may write atomic packing fraction like this, 4 into, we may write 4 into, I mean actually what the atomic packing fraction, the volume occupied by the atoms in the lattice, I mean in the crystal, cubic crystal divided by or whatever divided by the actual volume occupied by the your lattice cube. So, okay. So, here the what I told that the your number of lattice points per unit cell is 4. Okay. So, and so it will be 4 into 4 third pi your R n a cube plus this for the indicating that there is the ion, and R Cl minus cube. Okay, divided by the volume occupied by the unit cell. So, this is A cube. Now, put all this data here. After putting, you must get the value. It will come nearly I think 0.65. So, it is 0.65 only. So, this is the atomic packing fraction for sodium chloride and your which option will be correct. So, let us see here also option B will be 0.65, that means option B will be correct. So, for question number 10 option B is correct, option B, okay, 0.65. So, here I think nothing to discuss, just to put the value of the radius of the sodium and that of the chlorine, and then that value 5.6 its whole cube, just after calculation it is I think nothing to discuss about this calculation part. I hope you are efficient to calculate these things. So, this is the solution for the question 10, and thus we have completed the solution of all these questions. So, let us end here, and thank you for your attention.